Hello friends, thank you very much for watching this video. I am Mohamad and today we're going to be discussing how we can actually utilize AWS services in order for us to facilitate the communication between our .NET application. We're going to be utilizing SQS in order for us to send messages between one application and another. We're going to be discovering queues, messages, and basically why do we need them and how are we going to be utilizing and leveraging the cloud in order for us to facilitate the communication between our different .NET services. If you like this video, please like, share and subscribe. It will really help the channel. As well, if you'd like to support me, please consider supporting me on Patreon or buying me a coffee. With that said, grab your cup of coffee and let's get started.
We're going to start first by installing the components needed in order for us to build our application. So we're going to be installing Terraform, AWS CLI, as well as .NET. But before we do that, we're going to be seeing what are we going to be building today. So if I go back to my drawings here, so we can see that we're going to be building another Formula 1 application, and we're going to be seeing here that we're going to be building an application between a sender and a consumer, and basically the sender here is going to be the FIA app, and we're going to have a consumer which is going to be any of the teams that we're going to be building. So these are going to be the consumer. So the plan is we're going to be building an application, a .NET application. So we're going to make it here a .NET application. And this .NET application needs to send something to another .NET application. And basically what we need to do is once we build it, we want to send this information through a queue, which is going to be an AWS queue called SQS. So we're going to be utilizing the SQS service, which stands for Simple Queuing Service, which SQS provide. And once we need to send this any message, the .NET sender, or basically the FIA app, is going to send a message to through the queue, and one of the consumers applications which we're going to be building is going to be basically receiving this application. And we can see here that we have different teams, which is going to be different applications, and every single application is going to be we're not going to build 3 applications, but what we're going to be doing is we're going to just build it for one, and we're going to see how we can actually mimic it for all. But basically the main idea behind this is we're going to be building it. We're going to be building a sender and a consumer, and we're going to be basically utilizing AWS queues in order for us to send this message through it. So this is going to be the simple application that we're going to be building. So right now, if I go back to my terminal, we're going to be seeing the main components that I'm going to be needing in order for me to install these. And for this, I'm currently on a Mac, so I'm going to be using Homebrew to install all of these different packages. But if you're on Windows, there is all of the different installers which you can directly download once you search for Terraform, .NET, as well as AWS CLI. So let's see how we can install them through, first of all, through Homebrew. So here inside my web browser, what I'm going to be doing is for Homebrew is for AWS CLI, I'm just going to copy the command and I'm going to put it here, and it's going to tell me that's already been installed. Perfect. I'm going to take the same thing for Terraform, which is going to be brew install Terraform. I'll just type it, brew install Terraform, and again it's already installed. And for .NET, I have already installed it, so I put .NET -- version, and you can see I'm running on the latest version of .NET, which is going to be 7.0.305 by the time of this recording. So now that I have this ready, all I'm going to do is open this in Visual Studio Code, and now we can see it's open in Visual Studio Code, and inside my root directory I'm going to create a new folder. I'm going to go to Terraform, and inside this Terraform here, what I'm going to do is I'm going to create a variable file. I'm going to call it variables.tf. And inside this variable.tf, all I want to do here right now is just put the information that I want, for example, to input, like the queue name, how long do I want this message to be stored, etc., etc. So it's going to be pretty straightforward. So inside the variables here, first thing that I want to do is I want to define the queue name. So it's going to put variable, and then I'm going to put queue _ name, and then here I'm going to define the description for it, and I'm going to say the name of the queue that needs to be created. And then I'm going to specify its type, and I'm going to say it's going to be of type string. So that's the first variable. The second variable that I want, it's going to be called the retention period. And here, how long do I want to keep those messages? And I'm going to say the description for it is how long do we want to keep the message in the queue. And all I'm gonna do here, I'm gonna put the type for it is gonna be a number, and I'm gonna put a default value of, let's say, 80,000 seconds. I can do it however I want. This is just a number. Then what I want to do is I'm gonna get another variable, and basically I'm gonna put the visibility timeout. So I'm gonna call it visibility timeout, and here I'm gonna specify the description, and this means that the time, I'm gonna say how long we can say does the consumers have before the message is removed. And here, for example, we're just gonna specify the type. We're gonna say it's a number, and I'm gonna put the default is 60 seconds. And then the last variable I want to create is gonna be my receiver count. And it's gonna be pretty straightforward. So under description, all I'm going the number of times that message can be received before going to the DLQ. Let me move it a bit better, and then all I'm gonna do here is specify the default and the type. So I'm gonna put type equal number, and I'm gonna say default equal 3, and that's it. So here we can see that I have 3 simple variables: the queue name, the retention period, the visibility, and the receive count. On all of these, they're gonna play a crucial role inside my queues. So now that I have created the variables, all I'm gonna do is create a new file, and I'm gonna call it sqs.tf, and that's it. These are the 2 files that I'm gonna be basically creating. So now that I have created my variable, and now it's time for me to create my actual code for my queue. And here we're gonna start first by providing the provider, and I'm gonna say it's gonna be AWS. And then I want to specify basically my region that I want to operate in, and it's going to be EU-West-2. So now this region here is basically going to be the London region, and if I go back to my web browser and if I click on London here, we can see that it is the EU-West-2. Perfect. So now that we go back here, now I want to start creating my resources, and the first one is going to be AWS underscore SQSQ. And I'm gonna call this SQS notification, because basically what we want to do is we want to, within this application here, what we want is the sender is, for example, is try to send a notification for these consumers, like there's a red flag in the race, or there's a yellow flag in the race, or someone got any types of warning for driving, for example, outside the racing lines. So all the sender needs to send is these themes, that the warnings that's been generated because of the how the drivers are driving inside the race. So it's going to be a pretty straightforward notification. So here all I'm going to say is just going to be SQS notification queue. And the first thing that I want to give it a name, and for that I'm going to utilize the var queue name that I have created. So I'm going to utilize this queue name. Once I run it, it's going to ask me for it, so it's going to automatically populate it. And then I'm going to specify the message retentions in seconds. Again, I'm going to utilize my variable, and this one is going to be the retention period. Then I'm gonna specify my visibility timeout. Again, utilize the variables. Then I'm gonna specify the redrive policy, and this redrive policy is gonna be JSON. And inside this redrive policy, I'm gonna specify my DLQ. So let's discuss what is a DLQ first. So if I go back to my drawing here, we can see here that in this simple example, I have a queue which is connecting my sender and my receiver, which is pretty straightforward. But what happened, for example, if for any reason this application, my .NET consumer applications, either for Mercedes, Ferrari, or Aston Martin, is down? The application is being updated, for example, there is a problem with the code there, it's not able to process the messages, it has any issues by trying to connect to the queue even. So what happened in that case? we want a way where we don't want to keep that message in the queue pending for a long time. We wanted to move it into a different queue so we can actually inspect it later on and see what's the error. And in order for us to do that, we need to utilize a concept called dead letter queue. And the dead letter queue here is basically gonna be like another queue which is gonna be only available for only the messages which we're not able to process, or the messages that we're not able to utilize. And this queue here is going to be directly connected to the main queue. So in this example here, we can see that we have our sender, which is going to be our FIA app, and we have a receiver. It's going to be one of these teams. It's either going to be Mercedes or Ferrari or Aston Martin, and we have the main queue, which is going to be responsible for transporting the message between the sender and the consumer. But what happened if, for example, any of these consumers were not running? Let's say, for example, the application was updating and it was offline for a certain amount of time, or for example, there was an error, like a 500 error inside the application, so it's not able to process a queue. So we're going to be utilizing a DL queue where basically all of these messages which are unable to process is going to go directly to the DL queue. And through that, we are able to keep them, store them in that separate queue, and so we can inspect them later on, and basically we can see what's wrong with them. And through the DL queue, we are able to replay these messages again. So it's going to work to something like this. So I'm going to choose a queue here. I'm just going to put it on the side. And for this, I'm going to basically connect my main queue to this queue. And for this, all we're gonna be having here is, I'm gonna add the name for it, so it's gonna be called DLQ. And now for every single queue, we're gonna have a DLQ. So in this example, we're gonna have 3 DLQs. Here and here. Again, we're going to be utilizing the LQs again here, and another one here. So we can see here now, in total, I have, for this, in this example, I have one main queue, another DLQ, one main queue, another DLQ, and one main queue, and another DLQ. And these two are going to work together in order for us to link the DLQ. So any message within this queue is failing, it's going to go directly to the DLQ, so on and so forth for the rest. So now if I go back to my Terraform, and I want to build it, so the redrive policy here is where I'm gonna specify my DLQ, and I'm gonna specify it through JSON. So first of all, I'm gonna specify the dead letter queue, actually dead letter target ARN, and that's something that I want to specify after this. So I'm just gonna leave it empty for now. And the other one is gonna be the max receive count, and I'm just gonna make it equal to the var dot, if we take a look here, it was the receive count. So let's copy paste it. And now in order for me to fill this ARN, all I'm gonna do is I'm gonna create another queue. I'm gonna call it resource. It's gonna be AWS underscore SQS queue, and here is gonna be called SQS underscore notification underscore DLQ. And it's going to be pretty straightforward. So I'm just going to have the name, and I'm going to take the visibility. So I'm just going to copy these. I'm going to put them here. The only thing which is going to be the name is going to be different, where I'm going to utilize string concatenation in order for me to specify the name that I want. And let me take this out. And I'm going to put a $sign, brackets, and then I'm going to put dash DLQ. And now once I have done that, all I'm going to be doing here is I'm going to AWS underscore SQS queue dot SQS notification DLQ dot ARN. And now that should be able to work. Now with this sample line of code, basically less than 20 line of code, I was able to create a main queue, and I was able to create a DLQ for me. And I was able to connect them both together. So now let's see these in action. So if I go back to my terminal, I want to start implementing them. So if I navigate to my Terraform folder, I'm gonna just put Terraform in it. And now basically it's gonna be initializing my Terraform for me.
A few moments later.
And this should take a few seconds. Now we can see the Terraform initialization has been complete. And then I'm gonna put Terraform plan. And if you can see here, it's asking me directly what is the name of the queue that you want to create. And this is going to be the key thing. If I go back to my drawing here, I want to create the queue for the first between the sender and the receiver for the first one. And since the first team here is Mercedes, I'm going to put, it's called the Mercedes queue. So I'm going to call it Mercedes underscore queue. Actually, just Mercedes underscore notification. Can call it whatever I want, so I think that should be a valuable name. And now that I have specified it, it basically told me that there's something wrong with my code, and let's see. So it says here the var receive count should be a number, and for some reason it's not able to find it. So let's take a look at this code. So if I go back to my Visual Studio Code and let's look at this, we can see that I have my redirect policy equal JSON. JSON encode. Yeah, let's run this again. Mercedes underscore notification. Perfect. So now that my plan is working, we can see what is it going to be creating. It's first of all, we can see it's creating the DLQ. It's basically giving it this name, Mercedes underscore notification DLQ. Tell you what, let's change it from underscore to dash. I think that's a better approach. But other than that, we can see it's creating another queue as well here, which is going to be my main one, which is going to be the notification, Mercedes notification. So we can see I have my DLQ and my main queue. Perfect. Now let's run Terraform apply. Before I actually run this, I just want to go back to my web browser, and I want us to see that I don't have any currently queue available. So now after I run all of those, we should be able to see these two queues available here. So now Terraform apply, Mercedes dash notification. It's gonna start and it's gonna tell me, are you sure you want to create them? I'm like, yes. It's gonna take a couple of minutes, so let's just wait for it.
A few moments later.
Okay, perfect. So now we can see that my two resources have been created, and if we take a look at here at the information that's showcased, we can see that I have my main queue and my DLQ are created successfully. So now if I go back to my web browser and I do a refresh, we'll be able to see here that I have now two queues. We can see the main one for Mercedes notification and the other one, which is going to be the notification, the DLQ. If I click on this here, we can see the URL that I have for my queue, as well as if I click on the DLQs, we can see that it's connected to a DLQ, and we can see the maximum retry that I have provided here. And if I go to monitoring right now, because it's empty, we don't have anything there, basically we can see that everything here is now empty. So now that I have made sure that my queues are actually running and basically my queues are actually being created on AWS, the next step for me is I want to start right now by creating my two .NET applications. So one is going to be the sender, and then the other one is going to be the receiver. And in our case right now, the sender is going to be the FIA app, and the other one is going to be the Mercedes app. So let's go back here and let's start by creating .NET new web API dash name, and I'm just gonna call this what should we call it? Call it API. Let's not call it FIA. Let's call it API.FIA because it's gonna be the sender. Perfect. Again, I'm gonna create another one, which is gonna be .NET new web API. I'm gonna call it API.Mercedes because it's going to be the receiver. And one other item that I want to create here as well is a class library in order for me to share some patterns between the two. So what I want to do right now is I want to create a class library, and this class library is going to contain some common information like the message type, the message structure between the two, so I don't have to repeat the work between the two. So if I create it in one place, I don't have to duplicate it again in another place, and then this leads to discrepancy between the two. But if I have one single library which is being shared between the two services, now it's going to have a single source of truth for the two, and that's what I want to do right now. So in order for me to do that, I'm just going to create .NET new, it's going to be a class lib, and I'm going to call it API.contracts. Perfect. So now if I open it again in Visual Studio Code, and we can see everything was creating in the wrong folder. It's completely fine. I'm just gonna move them out, and now all I'm gonna do is just move the, oh, they are already out. No, let's close Visual Studio Code and let's try it again. Okay, perfect, now it is. So now all I'm gonna do is just drag these out. So move out, perfect, move the second one out, perfect, and move the third one out, perfect. So now all I have here is basically I have my Terraform code, which is going to be responsible for my infrastructure. I have my sender, which is the FIA app, my receiver, Mercedes, and the contacts, which is going to be in between. So now, in order for me to make this a bit easier, what I want to do is I want to install some packages so my applications will be able to recognize that I'm going to be utilizing SQS. And if I go back to my terminal, I'm gonna put ls so I can see here my 4 folders, and the first one I'm gonna go through it is my FIA app, so cd api.fia, and I'm gonna install my .NET add package, and this one is gonna be called the AWS SDK.SQS. Perfect. So now if I go back here to my FIA and I click on the CS Proj, we can see that my SDK has been installed correctly. Now I'm going to do the same thing for my Mercedes consumer apps. Again, I'm going to go to api.mercedes and I'm going to install the same package, .NET add package AWS SDK.SQS. Perfect. So now also this has been installed. If I take a look at the CS approach for the Mercedes, and we can see here that I have SQS installed successfully. Perfect. So the first item that I want to do here as well is I want to add a reference between the FIA app and the contracts console library and the Mercedes and the contracts console library. So first of all here, let's see how we can do that. Inside my terminal, I'm going to go back one folder, and if I, again, ls, you will be able to see everything. I'm going to clear my screen, type ls again, we can see the 3 apps. And I want to put .NET add reference, and what I want to do here is actually it should not be reference, it should be the api.fia CS Proj reference to what? To the API contracts, and this is going to be the first one, and now the other one is going to be .NET add api.mercedes API. Oops. Add reference to API.contracts, and now if I go back to my CS Proj here, we can see that for the Mercedes CS Proj, I am actually referring to the contracts now, and for the FIA CS Proj, I'm also referring to the contracts now. Perfect. So now that I have all of my libraries connected, now let's start building our contracts. So the first thing first I want to do is I want to remove this. I'm going to delete the default class, and I want to create a new folder, and I'm going to call this messages. And inside this messages here, I'm going to be creating my first interface, and it's going to be we'll call it iMessage.cs. And here it's going to be public. Actually, let's specify the namespace. So namespace, we're going to put api.contracts.messages, and then I'm going to put public interface, and it's going to be iMessage. Perfect. And this iMessage is going to be pretty straightforward. All it's going to have a string of type message type name, and it's only going to be a get. We're not going to be using the setter here. Perfect. So now the second item that I want to add here is going to be the actual message, and it's going to be called notification message.cs. Again, we're going to follow the same structure. The namespace, it's going to be api.contracts.messages, and it's gonna be public class notification message And the thing that I want to do here is I want to inherit from the iMessage, and then I want to specify all of the attributes that I need here. So the first one is going to be a keyword, so it's going to be the ID for every message that I'm going to be sending. And also I'm going to be utilizing here some attributes in order for me to make my life a bit easier. And I'm going to utilize JSON property name, and in the JSON it's going to be ID. It's going to here ask me to fix those references, so it's not asking me now because Visual Studio Code is an idiot. It's going to ask me later. I'm just going to put another one, which is going to be the type. So here we're going to basically referring to the notification type. Again, we're going to utilize the JSON property name as an attribute. And it's going to be type. And then we're going to put another property. We're just going to put here a string, and it's going to be the notification that we want to send. And let's copy this up, and we're going to put it here, and we're going to put this as notification. And lastly, we're going to put the iMessage parameter that we have added. It's going to be property string message type name, and it's going to be equal name of notification message. And for this, we're just gonna ignore it for now. Perfect. So Visual Studio is not being helpful in order for us to fix those dependencies, so I'm gonna add them manually, and I'm gonna put it before the namespace. So I'm gonna put here using system.text.json.serialization. Okay, so now why is it complaining? Oh, semicolon. So now if I go back here and if I go to my API contracts, .NET build, I should be able to build successfully. Okay, great. That's fine. I'm not really worried about it. Actually, what I can do for this, I can just make it equal string.empty. So now if I run this again, we can see the warning has gone, and then basically I can build succeeded. Great. So now that I have this available for me, the next step is I want to go now to my sender. So now let me close this. And before actually we do that, let us do a quick explanation of what is this. So here what we're doing is, because we said between the sender and the receiver we're going to be sending messages, and we can think about these messages as simple envelopes or which contain actual letters, and inside this letter we're sending any information that we want, and basically we're giving every single message that we send a unique ID. Then we're actually sending the type. So if, for example, if it's a warning, we're sending it. If it's, for example, a red flag or any types of flags there. If it's a driver penalty, that's a different type. If it is the race has stopped for any reason, that's a different notification. If, for example, the weather has changed and they need to take into some kind of precaution, that's a different notification, so on and so forth. And that's the type. Then we have the actual notification message. So now that we have covered why do we need the message, now let's see how we can actually utilize our code and the library that we have installed, the package that we have installed, in order for us to send the message from the receiver to the queue and then to the consumer itself. So inside my Visual Studio Code, I'm gonna go back to my my sender, which is gonna be the FIA app. I'm gonna create a new folder, and inside this folder I'm gonna call it services. And inside this first services folder, I'm going to create a new file, and I'm going to call it SQS publisher.cs. Pretty straightforward. We're going to start by the namespace. It's going to be api.fia.services. And I'm going to provide a class, which is going to be the public SQS publisher public class, I forgot the keyword class, and then here inside my SQS publisher we're gonna specify first of all private, my, again, read only, Amazon SQS, and this is here the SQS library or that I have installed, which is gonna be this one. Of course we need to add the reference for it. Again, Visual Studio is not being helpful at this moment as always, so let's add it manually, and I'm gonna put here using Amazon.SQS, and now I need to initialize this inside my constructor, so I'm gonna put a constructor here, and I'm gonna put Amazon SQS. Oops, here I forgot to put SQS. Here's gonna be SQS, and all I'm gonna do is underscore SQS equal SQS. Perfect. And now I need to specify my method, and this method is going to be responsible for sending the request, and I'm going to be referring to this method anytime that I want to send a message from my sender. So it's going to be straightforward. So it's going to be public async task, and it's going to be of type publish async, and I'm going to make the object as a anonymous, because basically here I don't want to link it to a specific types of message. Right now I have a notification message type that I want to send. Maybe later on I have a driver's point. Maybe later on I have, for example, the constructor's point. Maybe I have like some logistic notification that I want to send. Maybe I have, for example, different types of events which could be happening on the track, and this could be a notification. So I don't want to link myself to a specific type of notification. Or for example, later on I want to have a summary of the race that I want to send from the consumer to the sender, and it's not a notification. It could be any types that I want, any other type that I need. So for this reason I don't want to link it to only one type of message. So in this way I can inject the message type because it's going to be of notification. So because it's going to be of type anonymous. So here what I want to do then, I want to specify my queue name that I want to utilize, and then I'm going to specify here the message. And what I want to add here is I want to specify T as a type of iMessage that I have created previously. And if you remember, this iMessage here is going to be of using, again we have to refer to it manually, api.contracts.messages, because we're going to be referring to that one. And let's make this a bit smaller so we can see it all in a single line. And at the end here I'm gonna start defining my method, and this method here is gonna be straightforward. So first of all I'm gonna get my queue URL, and the way I'm gonna do that, I'm gonna utilize my SQS library that I have injected, and I'm gonna put get queue URL async, and I'm gonna specify the queue name that I have. Let's put here queue name, and let's update this to queue name. Perfect. And here this will provide the full queue URL, because right now if I go back to my web browser and if I click on this one, so this is going to be my full queue URL that's needed in order for me to send the message. And because here I don't want to have to dynamically, or basically I don't want to hard code this inside my application, all I want to do is specify just the queue name, and I will let the application to figure out how to find it from the SQS library that I have installed. So now that I have specified my queue URL, I need to specify the request, and it's going to be var request equal new send message request. And inside this send message request, I'm going to specify first of all the queue URL, which is going to be equal to a queue URL that I have got previously dot queue URL. So now let me fix those references here. Perfect. And let me fix this. Great. So now I have my QURL. The next item I want to send my message body, and the message body is gonna come from message. And to do that, I'm gonna utilize the serialization. So JSON serializer, and I'm gonna pass here the serializer.serialize. So let me fix those reference so we are able to see all of the method that we have. So serialize, and all I'm gonna pass here is the message, which is fine. And lastly, I'm gonna add the message attributes, and the message attribute here is gonna be quite interesting. So it's gonna be of type dictionary, and let's see how we can define it before. So we can see here it's of type dictionary. It's going to require a string and a message attribute value. And the message attribute here, we can think about them as the headers. So let's say we're doing an HTTP request, and we're doing an HTTP request. Other than the actual request body that we are sending, we have the headers, and the headers could contain information about the sender, if they have any authentication or authorization. It could contain correlation ID. It contains a lot of different data that's actually being useful, and it's actually being helpful in order for us to try to process this message. What we want to do here is we want to actually utilize these headers messages, and in this case the message attribute, in order for us to have the same implementation as a header but for a message. So here what we're going to add is we're going to add the message type, so it will make it easier for the consumer to identify the message type for serialization. We could add a timestamp if we want, but something what we need to keep in mind, headers could be up to 10 within headers we can put as many headers as we want, but with message attribute we have a limitation of 10 attributes per message, so we cannot exceed this. So we need to be very careful of what types of attributes we want to add, as long as we don't exceed the 10 limit that we currently have. So if we go back here to my source code, so the first thing that I want to add here is going to be the name of, it's going to be the type of message that I'm going to have, and in order to do this I'm going to put name of, it's going to be then iMessage dot message type name, and then I'm going to say this is going to be the name for it. And then after I do that, I'm going to specify here my new message attribute. Actually, let's make it on a new line, new message attribute value, and then this new message attribute value is going to be containing the string value, and this string value is going to be of type message dot message type name, and the other one is going to be the data type, and we're going to say it's going to be of type string. As simple as that. So now what we have done here is we have created a dictionary, and this is the first element in our dictionary. First element in the dictionary. And basically here we specified first of all the key for this dictionary, and this is here our type. And then here we specified the value, which is of type objects. And then once we have done that, let's say I want to specify another one, we can do again simply like this. Again, this one is going to be timestamp, so I can call it timestamp if I want. And again, I need to specify, new message attribute value, string value, and here for example I can say it's equal to date time dot UTC now dot, for example, dot to string, anything that I want, for example. And then after that I specify the data type equal to string. I have all of these different, again, this is the key, this is the value, etc, etc. I can even have versioning if I want, so I can specify the version of the message, so I can hide version, and then I can specify new message attribute and string value equal data type. Message value we're going to put v1, and the data type is going to be of type string. So so on and so forth. We can add as many as we want as long as it's less than 10. And then once we have that finished, all I want to do right now here is put await. And for this, I'm going to put underscore sqs dot send message async, and I'm going to pass my request. And why is this not happy? Let's see. Oh, okay, so this should not be here, and this should not be here. Okay, let's put this here. Perfect. And now this should be able to work. So now if I go back to my terminal and I'm gonna go to my .NET, actually let's see here, so cd API FIA and .NET, let's clear it up and then do .NET build. And you can see it's building and we got build succeeded. Perfect. So now that my code, in order for me to send message, is actually running, now what I want to do is I want to actually create a controller, and from that controller I want to refer to this so I can create the message. So inside my controllers folder, I'm going to create a new file, and inside this file I'm just gonna call it notifications controller.cs. and to avoid a lot of retyping, I'm just gonna copy all of this, go to my notification, paste it, and then just update the text. So it's going to be notifications controller, notifications. I don't need the weather information, let's remove these. And to be honest, yeah, I don't even need this, so bye. So now that I have a controller which is ready, all I'm going to do is change this to API /controller, just better consistency around that. And here all I'm going to do right now is create a new request. So I'm going to make it as HTTP post and public async task of action result. And here we're going to make it as post. And let's start first of all by defining a SQS client that we want to utilize. New Amazon SQS client. Let's fix this reference. Oops. And now let's pass the region because it's going to require a region. Region endpoint, and we're going to choose EU West 2. I think that was it. Let's double check this here. If we go down, EU West 2, perfect. And then what I want to do next is I want to specify the actually. So now let's create this sender, so we can just say it as a publisher. So var publisher equal new SQS publisher. Let's fix this reference, and here all we're gonna do is gonna pass the SQS client that we have just created, and then here all we're gonna be doing is simple await publisher.publish async, and we're gonna specify the type of message, which is gonna be notification message, and we're going to specify the queue, and then we're going to specify a new notification message. And then let's fix these references here. Notification message, perfect. And here if we go back to my web browser, I can see the queue name is Mercedes notification, so let's copy this and put it here. And now for this, what we're going to be doing is we're just going to specify the ID, and it's going to be a GUID, so we're going to put GUID.new GUID, and then I'm going to have the message type name, which is automatically going to be filled. Notification, we're going to see here we have a red flag in the session, for example, and then we can lastly, oops, So let's make this like this. And here what I want to do as well, the last one is going to be the type, and I'm going to say type equal 1. Anything that I want. And once that is done, all I'm going to return is return okay, that everything has went successfully. So now let's test this out. I'm going to go to my terminal and first of all do .NET build. We should be able to see everything is building. Now if I do .NET run, we can see that my application is running on this port. So let me copy this. Let me go back to my web browser. Let me open this here. I'm gonna put / swagger / index.html. And let me zoom out a bit. And we can see here that I have post notifications. And if I click on try it out, and if I click on execute, we got a 200. And now if I go back to my queues, and if I go see here to send and receive messages, and I put poll for messages, I can see here that I have one message available for me in the queue. And if I click on it, we can see here that we have a red flag in the session. If I look at the attributes, we can see the notification type, I can see the timestamp, and I have the version. For the details, I have different information about it, but the body is basically the information that I want, which is exactly what I want. So now what we have done, if I go back here, I was able to send a message. So let me put an envelope. So I was able to send a message from the FI app. Now it's actually send it from here. Now it's actually living in the queue. So now what I want to do is I want to create my client code, so I will be able to pull that message and able to analyze it. But before we do that, one small thing that I would like to add here. So let me stop the application. So I'm going to put Ctrl+C, and the one thing that I want to actually add here is inside my controllers, and I want to put here string and message, and I want to basically inject this, so it will be much more easier for me to test different messages. And now if I run this again, .NET run, perfect. If I go back to my web browser, I go here and I click on refresh. Now if I click on try it out, we can see I can specify the message that I want. I can say, for example, yellow flag in sector 1 and 2, for example, execute 200. If I go back here, we are still pulling for messages. Let me stop and let's pull. We have received another pull, and if I go here, we can see we have red flag in the session, so that's the first one. But if I click on this one, we can see I have yellow flag in sector 1 and 2, and we can see it actually converted it into Unicode in order for me to avoid any issues. So it automatically converted the AND for me, which is really good. So now that this is working exactly the one I want, I'm going to stop pulling for now. I'm going to go back here and start actually working on my consumer so I can actually see these messages. So to do that, let me close all of these. And let me close this, and I'm going to go to my api.mercedes, and here I'm going to create a new folder, and I'm going to call it services. And inside this services, I'm going to create a new class, and this class is going to be called SQS service.cs. Again, we're going to start first of all with the namespace, and it's going to be api.mercedes.services, and it's going to be public class SQS service, and it's going to inherit from background service. And let's discuss why does it need to inherit from background service. Because basically what we want is whenever my API is running, I want to have a background task which is going to be always running, trying to listen up for new messages. So whenever a message hits the queue, it's going to directly able to pick up that message and basically able to send it back to me. And so I can process it. So I want to have a background service running within my API in order for me to always be able to listen to those messages. And this is going to be the crucial part, because I don't know when a message is going to come. It could become now, in 10 minutes, and an hour from now, tomorrow. I don't really know. So for that reason, I always want to have a listener for that queue. As soon as the messages come in, I want to pull it out so I can actually process it. So now let's see how we can do that. Because I was able here to actually inherit from the background service, I want to add some certain code so it will work. First of all, I want to specify my private SQS service. Actually, make it read only I Amazon SQS underscore SQS. And now I want to specify this in my constructor. Again, I Amazon SQS. Here it needs to be capital letters, so let's make it capital. And let's fix this references. Fix those references. Oh my god, come on Visual Studio Code, you can do it, you're smart enough. No, you're not. Okay, now I'm gonna put underscore SQS equal SQS. Perfect. And now what I want to do, I want to start actually implementing this. So I'm gonna put protected override async task. So here we can see this execute async with the cancellation token is automatically gonna be provided for us through the background service. And because I clicked override, I'm able to actually override the default implementation that's available through the background service. And here all I'm gonna do is, first of all, I'm gonna get my queue URL similar to what I have done previously. So I'm gonna put var queue URL equal await underscore SQS dot get queue URL async, and I'm gonna specify here my queue. And again, if we go back to my web browser, we can see the queue is called Mercedes notifications. Let me see. Yeah, Mercedes notifications. So let me copy that. I'm gonna put it here. So right now, as you can see, we are hard coding the queue inside my consumer. This is not the best approach, but again, just for me to able to save time and basically able to accelerate this, we're doing it like this. But what you want to do is you want to save the queue name inside your app settings, and then you want to inject your app settings inside the I container, and then load that app settings whenever you call the SQS service. I have already covered this, how you can actually utilize app settings to inject it in different sections in previous videos. So if you don't know how to do it, please check those videos. But for now, just for simplicity's sake and in order for us to save some time, I'm just directly hard coding it here. So now that I have specified my queue URL, I want to specify right now, oops, I don't need this here. I want to specify right now my receive queue message. So I'm gonna put var receive request. It's gonna be equal to new receive message request. Receive request. Let's fix this reference. Receive message requests. And here all I'm gonna specify is the following. So first of all, I'm gonna specify the queue URL that I want to listen to in order for me to receive the messages. Queue URL dot queue URL. The second item is the message attribute names. And for now, I'm gonna listen to everything. But here, what we can do is we can actually start implementing the filtration. So if I only want to listen to one type of messages, I can actually implement it here. But for now, to make it easier, I'm gonna listen to everything. And for this to do, I'm gonna put new list of string, and we're gonna say all. We're gonna listen to everything. And lastly, we're gonna specify the attribute names. Again, it's gonna be equal the same, new list of string, and it's gonna be all. And apologies, this needs to be like this. When you change a keyboard, everything changes. You're used to like the placements of the characters in one place. Anyways, so now this is working as it should. The next step is I want to execute a while loop so I can continue listening no matter what, unless there's a cancellation token being sent. So I'm gonna put unless stopping token dot is cancellation token requested. So unless a cancellation has been requested, I'm gonna continue listening over and over again, and I'm gonna put var received response received response equal to await underscore sqs dot receive message async, and then I'm gonna here get the receive request that I have, and I'm gonna pass the stopping token as well, because in case it needs to stop, it will stop it from there. And I'm gonna say if receive response dot http status code is not equal to http status code dot okay, so it means that I'm getting a 405 or 500 or anything like that. It will not read it, but other than that it will read the message. And here all I'm gonna say once I have that is I'm gonna print out the body of the message. I can put no, in case it's not equal okay, let me print out the error. So I'm gonna put here console.write line, and I'm gonna print out the received HTTP response so we know exactly what went wrong. And I'm gonna continue so it will not stop the implementation of the loop. Else what I want to do here is going to be the most simple thing, is actually reading the message, and I'm going to put here for each, and it's going to be var message in received response dot messages, and for every message I'm going to put console dot write line, and I'm gonna put here message dot body, and then once I read it I want to remove it from the queue so I don't read it again and again. And to do that, it's gonna be also quite simple. Await underscore sqs dot remove actually not remove, it's gonna be delete message async, and here we're gonna specify again the queue URL dot URL, and I'm gonna specify message dot receive handler, so receipt handler. Perfect. And now that should be it. So now basically what I'm doing here is I created a service which is gonna be a background service, and this background service is gonna utilize the Aws Sqs, and basically I initiated a receive request in order for me to listen to a queue, and I'm telling it that you need to listen to all of the attributes name and all of the message attributes name. No, there's no discrimination here about it. Like I'm not really filtering anything out. I want to listen to everything, and I'm saying if the cancellation token, if a cancellation token has not been requested, continue, else you need to stop. And then what I'm doing here is I'm telling it to receive the messages and putting it in this response. I'm saying if this response is not equal to okay, just print out the error code and continue. If it is okay, just get the messages and print them out for me. So now that I have done that, the last item that I want to do is I want to update my program.cs, so this background service will be able to run as soon as my application is running and be able to pull this information out. So how do I do that? It's pretty straightforward. So inside my builder here, before I actually build the application, I'm gonna put services dot add hosted service, and we're gonna add this SQS service. And let's fix this reference. Perfect. And the other item that I want to do is I want to inject my Amazon service similar to what I've done previously, because if we take a look at here, it's basically expecting it inside the constructor, so I want to inject it in. So we can see here that it's expecting an Amazon SQS with the actual region. So I want to make sure that I'm passing it through to this hosted service. So I'm going to put add services dot add singleton, and then here I'm gonna specify if it's gonna be of type I, Amazon SQS, and then I'm gonna initialize it here, and this is gonna be of type new Amazon SQS client, and I'm gonna specify the region here. Let's first fix this reference so we are able to get the region autocomplete, and the region endpoint is gonna be EU West 2. Perfect. And now that should be it. So if I go back here to my terminal, what I want to do, I'm gonna keep this running, the FIA app, and I'm gonna create a new one here. But let's see if I can create let's see, new window, new tab, split pane vertically. Perfect. So now here I have my FIA app running. Now I'm gonna tell you what, let's stop it. Let's put pwd. Let's copy this, all of this, and let's run it again. And let's put this here, cd, and I'm gonna go back and put cd api.mercedes, and I'm gonna clear this. And what I'm gonna do here is .NET build first. So this is my client now. It's building successfully. Let me clear. I'm gonna put .NET run. We can see it's running, and we can see it's already starting to receive those messages. We can see we have a red flag that we have sent previously, and we have the yellow flag in sector 1 and sector 2. Now let's add a new message. So if I go back to my web browser here, and let's say I want to add a different message, and I'm gonna say like 5-second penalty for, let's say, signs for Carlos signs, and I click on execute. Now if I come here, we can see that it has been automatically received by my receiver, my Mercedes, saying 5-second penalties for Carlos signs. Let's say here I'm gonna say another one. For example, let's say like pit lane entrance is closed for any reason. Execute. We can see I directly receive this message, pit lane entrance is closed, and all of that is directly available for me. Whenever I send this message, I'm able to directly to receive it. And here we can see the benefit of this, because if for any reason, if this is failing, so I'm gonna stop this for now, and I'm gonna send I'm gonna put here v1, send it, v2, send it, v3, so we can have different 3 messages. And right now, if I go back to my web browser here, and if I click on send and receive messages, so first of all, if I start pulling, we should be able to see that I have 3 messages has been received because I have sent them. But if I start receiving this, if I run this application again, .NET run, and you can see here right now it's gonna start receiving this. So I'm gonna stop pulling from here, and we can see it start receiving those messages, v1, v2, and v3. And if I click on full message right now, this should be empty because there is nothing more there. It automatically emptied it out. So we can see here how this is all working. Even if my receiver is not working, the message is being stored for me in the queue. It's not been lost. It's there for me so I can utilize it. And as we can see here the power of utilizing queues, because basically it allows 2 services to communicate without actually knowing what other service is. So when the sender is sending a message, it does not really care who's going to be receiving it. All it cares, the message is going to be created and send it into the queue, and it's going to be the problem of the receiver to actually figure out the message and process it. And here we can see the power that queues provide. And within this video, if we want to do a quick summary, what we have done here right now is we have only focused right now on queues, and we have focused on how actually we are able to send a message between a sender and a receiver. And we can see the power of this. If we want to do a quick summary, first of all, we have created the infrastructure through Terraform. We were able to create a queue and a DL queue. Then we created the sender, and then we have created the receiver, and we've seen how we create a background chat for the receiver so we can always listen to it. And we have seen how we can actually create the sender post request, so we can actually process a message and send it through the queue. I hope you liked this video. Please like, share and subscribe if you did. It will really help the channel. If you'd like to support me, please consider supporting me on Patreon or buying me a coffee. Within the next video, we're gonna go a bit advanced in this, and we're gonna be seeing how we can actually implement SNS and SQS. So we're gonna be seeing how we actually apply a notification service, but that's for the next video. I hope this video was helpful and have a great day.